Hello and welcome back to Yale Lab. Since its initial release, the Gemini Multimodal Live API has offered exciting possibilities for building real-time interactive applications on the top of the live-powered model Gemini 2.0 Flash. You may remember that I have been actively exploring its potential through various projects, ranging from the interactive camera application or real-time screen sharing assistance. However, if you have been working on the Gemini real-time application development for a while, you must be quite annoyed by these certain limitations that are due to its early experimental stage. Even in this documentation, Google warns you to consider the following limitations of the Live API and Gemini 2.0 when you plan your project. So the biggest challenge is the audio plus video sessions are limited to 2 minutes. That often resulted in abrupt session terminations and loss of conversation context for your real practical project. And also the context window are limited of 32K tokens, which seems quite small among the current LLMs. Second limitation is a limited language support, because the initial lack of comprehensive multilingual support restricts the API's global application because it's only support the English at first. And then the absence of the built-in transcription is also a big challenge for our project development that required developers like me to implement a separate resource-intensive transcription pipelines. For example, in my implementation, I convert the audio output to the text content separately with another small model like Gemini 1.5 Flash 8B model to do this audio to text conversion. And then the previous interruption handling is also another challenge because the limited control over interrupter behavior made the previous model difficult to synchronize the front-end elements and manage audio playback effectively when the user interrupts the current model's speech. So the good news is that when recognizing these challenges, Google has quietly released a significant update to the API addressing these limitations and paving the way for more practical and commercially viable real-time multimodal applications development. So in this video, we will explore these key enhancements and demonstrate how they can transform your Gemini Live API projects. That we will cover a couple of things, like the new support of the voice and language, the interruption management, the token counts, the session resume mechanism, and the transcription, which has not listed in this documentation. So by the end of this guide, you will have a clearer understanding of what these features are and how to leverage them to build more robust and user-friendly, natural, real-time multimodal applications. Let's begin with a high-level overview of the system architecture, which may look quite familiar to you since most of our real-time applications adopt this server-client architecture. So this diagram illustrates the key components, including the Gemini session handler in the Python server with the Gemini Live SDK, and a client on the browser that provide WebSocket connection and the interface to incoming and outgoing display and playback. So here in the client, it captures the user input, including the audio and image data from the microphone and screen sharing, and render the assistance responses and transcriptions into the real synchronized audio played by the speaker and transcript text displayed on the UI widget. And for the WebSocket part, it provides a persistent and bidirectional communication channel between the client and server that transferred our custom message flow for control and function data. Now the server manages the WebSocket connection and orchestrates the interactions with the Gemini API by using the Gemini Live SDK and relays the data to the client. The Gemini Live API that's wrapped in the Gemini Live SDK processes the import of audio and image data coming from the front end and produce the real-time transcription, produce the audio response, and manage the session, metadata, and other signals to the Gemini session handler with other stuff. With this architecture in mind, we can examine the new feature one by one in detail in our application. In this video, we will focus mainly on the backend as it's related to interacting with the Gemini Multimodal Live API and the SDK. For the front-end design, I create a client application under the Vite framework to demonstrate how to communicate with the backend service via the WebSocket and how to render the audio and text with the UI widgets. You can find the messaging protocol in this tutorial and the entire source code in my GitHub repository as well. Now we are going to review the new features, including the code snippets and practical considerations. So before starting the function exploration, make sure you install the Gemini SDK from its GitHub main branch instead of the PyPI library directly, because the new features have not been formally released on the PyPI package until the moment I made this video. And this is our old project code that's including the necessary functionality provided by the older version of Live API. And now the first change is that the model name has changed from Gemini 2.0 Flash EXP to Gemini 2.0 Flash Live for the multimodal preview function. But the previous model is still valid for this transition period. Although we don't know whether there are differences in performance between the old and the new model, it's better to switch the new model very soon, okay? And then in addition to the response modality with audio output and the system instructions that directed the model behavior, we can now add more configurations in the speech config parameters with the voice config, pre-built voice config with the voice name, Corey, or any other voice options in the list. And also there's a new parameters called language code, which is a configurable output language setting. Now you can expand your AI product to global user. Now we can change the language code from the EN/US to the CMN/CN for Chinese Mandarin. If you're interested in changing other language, you can refer to its documentation to find the language code is supported right now to follow the BCP 47 format to switch the language to this list here. An advantage of this multilingual voice support for Gemini is that you don't have to match the voices to the language just like the other TTS models do, meaning all the pre-built voices can speak all the supported language. Now let's try running the code to see how the Corey voice speak Chinese. You see the WebSocket server is running on the public IP with 9084 as a port. This is our front-end application. Let's start to share some screen. 嘿，这个网页在说什么内容啊？
这个网页似乎在讨论 Gemini API 的相关文件，特别提到了音讯转录配置和内容生成的设置。您想了解更多关于哪个部分的内容呢？
Can you explain to me the menu of this page?
在页面的左侧，您可以看到 Gemini API 文件和 SDK 的菜单，包括了概览、API 版本、功能以及不同程式语言的 SDK。您想了解这些菜单项中的哪一个呢？
So it looks good for multilingual support. You will also notice that the definition of the configuration parameters is becoming more structured by the type validation that ensures the settings are more robust than the pure Python dictionary. Now let's move to the interruption handling part. So interrupt is a very basic and important case for human conversation because it allows the user to change the topic, correct the misunderstanding, or simply interject with a thought without having to wait for the AI to finish the entire response. So as a real-time AI assistant, the Gemini Live model should also be capable of natural interrupt handling. With the new updates, user can now seamlessly interrupt the model's output at any point. So the model's default settings allow the interruption, so you don't have to open it in the configuration package. The integrated voice activity detection module inside the Gemini automatically cancels the ongoing generation upon detecting an interruption and generates a signal in the message flow that we can receive from our backend service by put the code detection code here, that when we receive a new response that including the server content, that inside of the server content there is an interrupted parameter which is not none. So that is the interruption notification from the Gemini API, and we can use our WebSocket to send our custom interruption message to our front end to let the front end to do the follow-up actions. So in this implementation, our front end will use this message to immediately stop the ongoing audio playback and flush the buffer for unplayed audio, which ensure the model reaction to the user's interrupt import sounds smoother and natural. Let's quickly check this code in demo. So I will change back the language to English, and then I will firstly ignore the message by not sending any interrupt message to the front end. Let's see how the system works. Hey, what do you see on this page?
On this page, I see the Gemini API documentation, specifically the API reference. It includes information about context window compression, audio transcription configuration, and various methods and events related to bidirectional content generation. Is there something specific on the page you would like to know more about? I see a menu listing capabilities, SDK references, and other items on the page. Is there anything specific on that list you'd like to discuss? Okay, the menu on the left side of the screen is titled Capabilities and lists options.
It seems that the front end cannot recognize the interruption and continues its ongoing audio playback, and then the next generation will come in the pipeline, slowly displayed. So let me uncomment this sending to make sure the front end knows currently there's an interruption coming. Let's restart. Refresh the front end. Hey, what do you see on this screen?
On this screen, I see the Gemini API documentation.
The menu.
I see a menu on the left side with options like Overview, API versions, Capability.
Top menu?
At the very top, I see Google AI for developers, models, solutions, code assistance, showcase, and community. Is there anything else I can help you find? This page mainly discusses the Gemini API, including its capabilities, models, and methods, as well as
API? What's language of this?
Do you mean what programming? The text on the page is predominantly in English. Is there anything else I can help you with?
So the interruption handling is very natural, right? The model is very sensitive to your input interruption and behave like a human conversation. Now let's move to the token count. Let me quickly add the code here. By detect the usage metadata field, which is newly added to the Gemini API, which now provides the total number details of the tokens consumed during the session. So here I just use the total token count from this usage metadata to give an idea how many tokens that we use for a single chat conversation. So I think the adding of this field is a good sign that indicating the Google is going to release the production of this live API very soon, because you have to calculate the tokens for the paid quarter and managing the resource. So let's see how much tokens we will be using. Hey, can you describe the code in this page?
The code on the page is Python code that gets the token count using the Gemini API. Would you like a more detailed description?
Yeah, please explain the detail of this code.
Okay. The code connects to the Gemini 2.0 Flash Live 001 model using the AIO Live Connect function, sets up a session, sends the text "Hello World," and then prints the total token count from the usage metadata in the return server message. Does that help?
Then what about this code?
That code iterates through the response token details, matches each detail, and prints the modality and count for each one. Does that make sense?
What about this new code?
This code is for configuring session resumption. It connects to the Gemini model, sets up a session, and includes logic for handling session resumption updates. Did you want a more detailed explanation?
We'll see each audio response from the model, which may last about 20 seconds, I guess, will consume 4,000 to 7,000 tokens totally. That's give you an idea how many tokens we will consume during the conversation. Previously, the Gemini Live API imposed a strict session limit that I've already explained. So that's resulting in the random disconnections and the loss of viable conversational context. Now this new session resumption function addresses this critical limitation by enabling you to build applications that maintain continuity and provide a more seamless user experience based on the chat history under the limitation of 2 minutes or 15 minutes session limit. So the usage of this session consumption is by using the handle that synchronized with the previous chat context. So we are going to create two functions: load previous session handle and save previous session handle to manage the handle that received from the API and save that handle into a JSON file that can be used across the sessions and application reloading. The actual session handle is just like a token that registers in the Gemini that's pointing to the chat history in the Gemini's data center. So we will load the handle at beginning of this app. That is implemented also in the receive from Gemini as a part of the response, which carry in the session resumption update. In that update, we will retrieve this handle in the update object, and we will save that handle into our file to make sure every time when the app begins, it will remember our previous session of chat. Then we need to add another new field to the configuration message to make sure that the model knows we have a previous handle that need to be aware by the model from the beginning of the chat. We put our previous session handle into the session resumption config, and that config will let the model have a certain memory. But you must be aware that this memory is not a long-term memory, because your handle that's stored in the Gemini server will not be last a very long time. So if you want to store your chat conversation in a long-term memory, you should still use the mem0 mechanism that I have explained in my previous video to implement a long-term memory. Okay, this session resumption feature is just to let you to continue the immediate chat conversation if the current session has been cut off by the session limit of the model. So let's try how this short memory works. So first, let's remove this session file because the handle here is not available right now on the Gemini server. Let's run the code. So let's initiate our first conversation with the model. So in this case, I will use a storytelling case to see how the model performs the short memory. Hey, could you read the first paragraph of this story?
Sure. The first paragraph says, Dr. Tomas Stryer looked around the control room at his team of scientists and engineers. He was excited and frightened, but he tried to seem calm. In a few minutes, they might start to discover something amazing, how the universe began. Can I read another paragraph for you?
And the second paragraph, please.
He looked out of the window at the beautiful blue summer sky and tried to breathe slowly. Should I read the third paragraph as well?
Yeah, I would like to hear the story later.
I'll be here when you're ready to hear more of the story.
Okay, so here you can see the resumed session update with the handle. After each pair of conversation, there will be a session update handle sent from the model to help us to record that handle of the previous session. So let me close that. And you will see there's a new file. Record our last session. And restart the server to pretend there is a termination by the session limit. Refresh. share the story again. Hey, could you continue reading the story for me?
Okay, so I should start with the third paragraph?
Yes, correct.
Here's the third paragraph. Ready, he said. He pressed the first button, and the complicated computers and machines came to life. Shall I go on?
No, that's enough. Thank you. Thank you very much.
You're welcome. Do you have any other questions?
Okay, great. So you see that when we restart the app, the model still remember where he stopped at the reading of this story, right? That's a big step for us to resolve the challenge that created by the session limitation. Last but not least, we will move to the transcription part. Now, the model provides its own transcript in streaming that support the audio and text output in the same time. So the implementation on the server side is very simple. Just add a new message retrieving from this received from Gemini. That check the server content with the new fields, output transcription and input transcription. So now even in their documentation, there's no clue that they have provided this transcription. So it's very new. And when I test with the source code, I found that even the input transcription has not been implemented yet. So currently you can only read out the output transcription, means the Gemini's response text from the message workflow. And in the message format, they provide a text field with the text content of the transcript and the finished field to let you aware that the current streaming of this text flow has been finished. But right now, even in the output transcription, the finish part has not working. So in our case, we want to display the text in streaming style, but close the message block by detecting the end of this streaming generation from the turn complete message. When the turn complete coming, it means that this round of the audio and text output has been finished. So we will send additional message to our front end via WebSocket by sending the text with non-content and the finish marked as true manually. So in the normal, we just send the text one by one, and with the send Gemini, and the finished has not been worked right now. Even we will use the finished field from the output transcription. So the code is here. Once they upgrade their code with the finished field and the input transcription implemented, the current code base will be fully working. Oh, before you run the code, you need to make sure that the output audio transcription parameters should be initialized by the audio transcription config object. Even there's no other parameters required in this initialization, you should always put this field set in the configuration message. Okay, let's run the code. Let's refresh this front end. And in this client app, we've already implemented the chat history section that lists the text content received from the backend, including the Gemini's output and the user's input that provided by the transcription features. But right now, we only can display the model's output because the input transcription has not been implemented in this API. Let's see how this works. let the model read the story again. Hey, could you continue reading the story? Maybe the third paragraph?
Okay, the third paragraph says, "Ready," he said. He pressed the first button, and the complicated computers and machines came to life. Do you want me to keep going?
Yeah, please keep going to read another paragraph.
"Set," he said. He pressed the second button and switched on the large particle accelerator that lay under the towns and fields of Switzerland. Should I continue?
Okay, so the chat history has been implemented well. And you see that the streaming is very quick even for a long context. It will not consuming a lot of time, just like our previous manual implementation of the transcription function. That's a great progress. Please explore these new features by yourself, including customizable voices, seamless interruptions, persistent sessions, real-time transcriptions, and also the other updates that not covered in this video, like the VAD, switch on and off, and sliding window context that help you secure your token usage to make sure that your token consumption will not exceed the rate limit. By using these new features, you can build more engaging experience for your users for sure. Again, find the complete code on my GitHub repository that's listed in the description below. Have fun developing, and I will keep you updated by tracking the new features in the future of Gemini.